Because my other recording isn't very good.
Did they hear you?
Yeah,
They could?
you can hear me.
No, they can hear like,
Can they hear you guys?
yeah.
Sometimes.
Oh, boy. I didn't.
Okay, you guys, let's multiply that out, and I'll rewrite it. It's x plus 2, x minus 2. So when you multiply the first ones, you get x squared. And then when you do the outers, you get minus 2x. You do the inners, plus 2x. And then you do the last, minus 4. Something's going to happen there. Oh, we're missing a marker.
Do you know how to multiply? Like 2?
This is a positive 2 and a negative 4. Negative 2, negative 4. But what happens here, Joey? What happens there? It cancels out. So you get x squared minus 4. What happens in the next one? Y. You get x plus 3 times x minus 3. Why is it going to cancel out? I get x squared. Then I do the outers. I get minus 3x. Then I do the inners, plus 3x. And then I do the last. The last is always going to be negative. Positive 3 times a negative 3 is a negative 9. And if you simplify that, you get x squared. And the positive 3x and the negative 3x is always going to give you 0. So it's x squared minus 9. There's something special about these numbers here. Oh, really? Do the next one. Can you just give me an answer? It's a plus 10, a minus 10, a plus 10. What'd you get? That's right. Okay, DeMonte, a times a is a squared. And can we do this in our heads, or do we see it yet or not? This is a minus 10 and a plus 10, which is 0. It's minus 10a plus 10a. Oops, don't forget the a. And then minus 100. By the way, some of you do forget the letters. Don't forget the letters. And what happens to the minus 10a and the plus 10a? They cancel. Now, if I didn't have a minus 10 and a plus 10, this wouldn't work. It's working because of that pattern there. These go away, so I get a squared minus 100. So read the problem carefully, because unless it's exactly the way it has to be, x plus the number, x minus the same number, it's not going to work. How about the next one? Jay, can you give me this one? It's J. B minus 5, B plus 5. No, can you just give me the answer? Because what's going to happen to the middle terms? A minus 5b and a plus 5b gives you how many b's? No, minus 5 plus 5 is 0. So you're going to get what? B squared 5b. Okay, there's more. 5b. And then the last one, minus 25. What happens to the 5b and the minus 5b? They go away again. You see that? So I get b squared minus 25. There's something special about these numbers. Anybody recognize what they are? The numbers look like, these are all special numbers. What's special about these numbers?
Oh, a number.
Oops, I missed one. Okay, they're perfect squares. So what we're going to do is we're going to be given the result, which is a binomial, and find the two binomials that gave that to you. These have to be perfect squares. X squared is a perfect square. So you're going to have an x minus, let me slide this. You're going to have x minus a, x plus a. These numbers here are going to be the same, but opposite in sign. One's a positive, one's a negative. And when I see something like this, I can recognize it. We can also do the x game too. So why don't you try the next two? Because I noticed I put these on here because I knew we had some problems with these. Because a lot of you want to distribute that 2 with the x plus 2, but it's easier to multiply the other ones. These are single numbers. I can do 2 times 3 times 4. I can do 2 times 3 first, or I could do 3 times 4 first, but I can only do 2 things. I could even switch the 4 and the 3. I could do 2 times 4 times 3 and do those first. Okay, and why am I bringing that up? Because in geometry, they're having a hard time with that. Because they have a half in front. They don't like the half. But I get the same answer no matter how I do it. So it's easier to do this first and then take that answer and double it. It's much harder to FOIL that, to take the 2 through the x plus 2 and then FOIL it. Just trust me on that. It is. So what's x plus 2, x minus 2? Can you go to the quick way? These are going to be the same numbers, but they're opposite in sign, so I'm going to have what? Emma, do you know? X squared minus 4. Good. Jesse, you got that? X squared minus 4, and then we're going to distribute. So it's 2x squared minus 8. Well, guess what I'm going to give you on the next slide? I'm going to give you that, and we're going to come backwards, but we're going to start with the easy ones first. How about this one? It's a negative 3 times x plus 3, x minus 3. So it's negative 3 times, that's right, x squared minus 9. Is that okay, Nick? Pierce, is that okay? Be careful though, it doesn't always work. It only works if those are the same number but opposite side. If you have x plus 3 times x plus 3, it doesn't work anymore. It's a different pattern. So it's negative 3x squared, and then don't forget to distribute. What's that going to be? What's a negative 3 times a negative 9? Matt? Close. 3 times 9 is bigger. Plus 27. It's Friday. You only have a 4-day week. Bruce would watch your time for class. Because we have, next week is the end of the quarter, so if you have any makeups that you want to do, any retakes, it's all got to be done by next Thursday. Okay, ready for the next slide? Let's back this up. Oh, I still have some more multiplying. How about Jack? Can you do this one? It's a minus 10, a plus 10. So I'm going to do the inside one first. What's that going to give me? Yep. Okay. And then the left. Minus 100. What's going to happen to the A's? Do you have to write it? No. So I get 5 times a squared minus 100, and I get 5. Joey, what am I going to get now? 5. Excellent. Minus 500. Okay, Hannah, how about number 4? Now, this has a negative sign, so of course that makes it harder. Do I have my fancy pattern here? Minus 5 plus 5. Remember, all we're ever going to do are factor the ones with ones in front. So this is going to give you a negative 4. And what's that going to give me? Hannah, do you know? What's the first one's going to give us? B squared. What's going to happen to the middle ones? I don't want to write them. Do I have to write them? No. They cancel out, and then I'm left with, Hannah, what's left? Negative 25. Okay, multiply that out. Matt, what do I get when I multiply that out? Well, first I have to do this. Negative 4b squared, don't forget the letter, and a negative 4 times a negative 25 is plus 100. This is the common factor, that negative 4. We always, when we factor, to reverse the process, we do that first. Is there a common factor in number 1? I have x squared minus 1. Write it so we can read it. Sorry, I did a little bit small in the typing. I made it bigger, but it's not big enough. How about that one? X squared minus 1. Is there a common factor other than 1? Nope. But now, I want to recognize this. This really is this. It's x squared, and there's a minus 1. Must be me. And how many x's, just plain x's, do you see there? No, I see an x squared there. I just want x. There's a trinomial there. How many x's do you see? Now I see 1. But how many are over here? Are there any x? No, that's x squared. I mean a box that's labeled just x. I don't see any x's there. Isn't that 0? What is 0 times x? 0. Isn't that the same as x squared minus 1? Why did I do that? Because when we put the little x game in here, what are you going to put over here? No, on the left side, well, let's do the right side. That's negative 1. There's a number there. What number is there? It's 0. So I'm going to fill in these spots here. I want to find two numbers that multiply to give you 1. Forget the negative sign for the moment. There's only one possibility. It's 1. But now I want them to add or subtract, because that's minus. So we subtract to 0. So one of them has to be what? Negative. Now, if I add these up, do I get 0? Yes. So what's the answer here? X plus 1, x minus 1. If I recognize it, these are perfect squares. When you get a binomial, two terms, and I have a subtraction sign between them, I'm going to look for perfect squares. And when I look at problem 2, is 48 or 3, either one of them a perfect square? No. But is there a common factor here? What's the common factor? What goes into both of those? Yep, they go fast. They should go fast. 3 goes into, well, you know what? If I don't know, I'll divide 3 into 48 and see if it goes evenly. It does. Does anybody know how many times? It goes in 16 times. Is 16 a perfect square? Yeah. So either you could say, oh, that's the difference of two squares, and these numbers in the parentheses here will be the same. It'll be the square root of that, but one will be positive, one will be negative. I divided 3 into z squared minus 48. Are you asking about the first problem or the second problem? Yeah? Well, multiply it out. How do I know? You always know. Multiply it out. Nope. Nope. Because you have to write this step first. Yes. Because you can't do it in your head because you're wrong. Now, let's do the 3 is still there. Now I want to figure out what did I multiply to get that. Now, if I put the x out here, what goes over here? Just the constant term. This is going to be negative 16, and what number has to go here? The middle term's added to what number? How many just plain z's are there? There aren't any. So this has to be what? It has to be 0. Because you don't see any z's. I see a z squared, but I don't see just a z. Is that okay, girls? Okay? What numbers multiply to give you 16? Now, Mrs. Arterson was giving her kids a multiplication table, but we don't have to do that. You have a calculator. You write down all the factors of 16. 1 times 16, 2 times 8, 3 doesn't work. 4. Now, that's a negative sign, so what am I going to do with these? Add or subtract them. If this is a negative sign, we're going to subtract. Which ones will give me 0? The 4s. And what does one of them have to be to make it go to 0? One's got to be positive, one's got to be negative. Does it matter which is which? No. So this is going to be what? Z plus 4, and this is Z minus 4. So that's not your answer. By the way, the fundamental theorem of arithmetic is that there is only one answer for these when you factor these. This is called prime factorization. So before I can do number 3, I have to do something with it first. We always look for the greatest common factor first. What goes into negative 2c squared and 50? Emma? What divides into both these? Well, I want it to be a positive c squared. Sarah? Well, I want a little more than that. I want a positive c squared. Right now I'm going to have a negative c squared. I don't want that. So let's make it a negative 2. We always want our x squared or whatever to be positive. Now, when I divide that out, negative 2 into 50 goes how many times? 25. Is it positive or negative? Negative. If you did get a positive, you can't do it. If you make a little x, you'll find out. Okay, let's do the x. What goes over here? Joey? What number goes here? Good. And what goes here? 0. Because there aren't any, well, we let it with c's. Just plain old c's. But what numbers are the same but opposite? They're multiplied to give you 25. Square root it, because it's always going to be that. 5 and negative 5. But the problem is, will you recognize it when it happens? If you're looking at two terms, you need to be thinking, oh, I bet it's one of these special ones. Now, do I need to write the negative 2 down again? Friends? Yes, I do. And some of you on your worksheet didn't do that. That's why I correct it, so I know that that's the mistake you're making. Because by the time the summative comes, it's way too late. I got to fix that question now. So then this is C plus 5, C minus 5. I could reverse those, it doesn't matter. So why don't you guys try that one? Oh, that one's a little harder. Nine doesn't go into 3. Okay, Sayla says 3. Is there anything else that's common? What else is the same in both of these terms? The x's, how many, what's the maximum I can take out? 1. Now, last class had some troubles with this. 3x times what gives you x cubed? A lot of my students put in x cubed. If I multiply that out, what do I get? X to the what? No, 1 plus 3 is 4. I don't have x to the 4th. So the cube must be wrong. I'm going to take 1 away from the 3. So how many will be left? 2. Write that, take away. Okay. Now 3 goes into negative 27 how many times? Positive or negative? Negative. If it's not negative, we can't do the problem anyway. And x is already there, so I don't need it. Now can you factor the x squared minus 9? So it's 3x, that's still there. Do I need the little x box again? It's x and x. Because it's minus 9, well, if you need it, then use it. What numbers add to negative? Multiply to give you negative 9, but add to nothing. Either 1 times 9 or 3 times 3. 3 times 3. One's positive, one's negative. It did all that. Because it was the common factor here and here. Well, we have one more problem, and then we'll do the worksheet. Yeah, you should do this with me, Jane. So, this is what? Plus 3, minus 3. Yeah, be right down. Okay, how about number 5? 5 looks tricky. You're going to get 2 worksheets. You're going to get this one, and then you're going to get the review one, and you need to work on the review one. You need to work on the review one over the weekend, because we lost yesterday, remember? What goes into both of those? Demonte, do you know? What's the same in both of those? What letter? D. What's the most I could take out? I have 4 here, I want to take them away. And 2 there. Can I take away 2? Sure. Now, I also don't want that negative sign there. So I'm going to pull the negative out. Then this is going to be what? Now, I took 2 away from my 4. How many are still left? 2. And then a negative d squared times what gives you a positive d squared? Okay? What's this going to be? A negative d squared times what gives you a positive d squared? Negative, not d squared, that gives me d to the 4th. I took d2 away, there aren't any left, so there's a 1 there still.
Yeah.
If you have 2 terms, you're going to have to end up with 2 terms. And let's do this. Now, do we need the x's or not? How do you get d squared minus 1? What's the letter? D and D. What are the numbers that multiply to give you 1? Only one possibility. 1 and 1. And I want them to go away. So 1 must be plus and 1 must be minus. If you want the x, put the x in.